So here's this outline for this video that explains the area of a circle without using calculus. So first an explanation by splitting up the circle into slices, and then an explanation by splitting up the circle from inside to outside, and each part of that explanation is modeled by pipe cleaners.
Here we have a circle split up into 5 parts. Let's rearrange the parts and then do the certain rearrangement for circles with more and more parts, and see if the rearrangement gets closer and closer to a certain shape. So what happens as we split up the circle into smaller parts and do this rearrangement? We get closer and closer to what? A parallelogram. Now note that this rearrangement will have the same total area of the original arrangement of the circle because all we did was rearrange. We did not change the total area. Now the area of a parallelogram is base times height. This would be the base and this would be the height. Now where would we find this length of this height of the parallelogram in the original arrangement of the circle? It'll be here. What do we call this length of the circle? Radius. So the radius would be the length of the height of this parallelogram. Now what about base? Well, first let's talk about 2 times base, and then we can figure out it for base. So here is 2 times base. Where would this be in the original arrangement? It'll be here. What do we call this? The circumference. So this part here, the 2 yellow lines, which means 2b, that is the circumference. So b will be half of the circumference. Now what is the circumference? It is 2 pi r. So the base would be just simply pi r. And so the area of this parallelogram, and also this would mean this would be the area of the original arrangement of the circle, would be pi r or pi r squared.
So we'll be rearranging parts of the circle. Of a quick side note, when I was rearranging, I accidentally switched up the second longest part with the third longest part as shown in the video, but I later fixed this, also as shown in the video. Anyway, by rearranging, you will not change the total area but just rearrange the parts. So the area of the new rearrangement will be the area of the original arrangement of the circle. Now, what is the area of this rearrangement? Well, first of all, what is the shape? It looks a lot like a triangle. However, you may say that this line here is a bit jagged, it's not perfectly smooth. However, as you get more and more parts of each part having less and less width, this line becomes less and less jagged and more smooth. Okay, side note. How do we know that when we have infinitely many pieces that this line will be straight and not curved like a parabola? Well, first of all, one of the assumptions is that the width of each piece is the same as the width of any other piece. Let's call that width x, and so the width of each piece would be x. What would be the length of this piece? Well, going back to the original arrangement, here it is. It is the circumference of one of the inner circles. So let's call that C1. For this inner circle, we have a radius, and so let's call that R1. So this length would be C1, and we also know that C1 is equal to 2 pi R1. What would be this length? Well, going back to the original arrangement, here it is. It is the circumference of another inner circle. Let's call that C2. Now what would be this length? Well, it's the width of one of the pieces, and so that would be x. What about this length? Well, that would be the radius of the second inner circle, and so let's call that R2. And so the length of this part would be C2, and we also know that C2 is equal to 2 pi R2, and also that R2 is equal to R1 plus x. Now using these equations, we get that C2 is equal to 2 pi parentheses R1 plus x. Using the distributive property, we get that C2 is equal to 2 pi R1 plus 2 pi x, and we get that C2 is equal to C1 plus 2 pi x. So that means that each length increases by 2 pi x, as we could do this for any 2 adjacent pieces. Now, as x is constant for any given problem for this example, that means that 2 pi x is constant for any given problem. for this example. That means that this line is linear and this line is straight and not curved. Now, what is the area of a triangle? It is 1/2 base times height. Now, this would be the base and this would be the height. Now, where would you find the length of this base in the original arrangement? Where would you find the length of this height in the original arrangement? Now, for base, that is the sum of all the widths. So where would it be for the original arrangement of the circle? It will be here. Now, for height, that was the length of the longest part. And so that would be here for the original arrangement of the circle. Now, what is the name for the part that I marked as B? For the circle, it is radius. What about for H? That is circumference. And so the radius is the length of the base of the triangle, and circumference is the length of the height of the triangle. Now, circumference is 2 pi r, and so the area of this triangle would be 1/2 times r times 2 pi r. Simplifying, we get pi r, and that would be pi r squared, which would be the area of the rearrangement and also the area of the arrangement of the circle. Thank you for watching this video. If you would like to, feel free to click on this playlist to watch more similar videos.